Okay, we're doing an example from 5.4, and we're taking the idea that the integral is the area under the curve, and we're applying it literally to the graph. So they've given us this graph, and they want us to find the gray area. So in other words, we are finding the area under the curve. Now you'll notice this crosses the x-axis. This means we have to actually evaluate this in two parts, from here to where it crossed the x-axis, then from here to the end. The reason is because when you write this out, you're subtracting the two parts here. So in this case, the x-axis minus the graph. Well, here it's going to be the graph minus the x-axis. This will change the signs, as you will see here in a minute. And so we're going to have to evaluate this in two parts. Now hopefully you can see just by looking at this that this crosses at 9. If I put in 9 here, the square root of 9 is 3, 3 minus 3 is 0. But obviously all I'm really doing is I'm setting this equal to 0 and solving. And of course that's, the simplest way to make sure you're not screwing up if you don't easily see it. And sometimes, you're thinking about other things and you just don't see it. Okay, so what I'm going to do is I'm going to start by writing out this. And I brought up paint, even though my handwriting is horrible on it, so that you can see what I'm doing as I'm looking at the graph. So first I'm going to start here with 0, and I'm going to go to 9 where it crosses the x-axis. And so from here I'm going the x-axis, and the x-axis, remember, is y equals 0, so this is 0, minus the graph, which is the square root of x minus 3. And this whole thing is dx, because remember it's the integral. And you might think this is a lot of parentheses, but the sign here is important, and I want to make sure that I apply the sign to the entire part. And so to make sure of that, I'm writing in all these. Okay, then I'm going from 9 to 16, and this time I start with the graph, so square root of x minus 3 minus 0. So there's the x-axis. And this two-part definite integral is what I'm going to be evaluating. And so all I've done is I've broken it up into two parts, here to here and here to here. And I'm just subtracting this from it. Now you can see this, normally we've been evaluating integrals where we're just using the x-axis and it's assumed, because this of course is going to disappear, that we're just looking for this. But here you can see we're going up, so it's going to change the sign. So what I'm going to do is I'm going to bring up the camera, and let's switch to paper. So hopefully my handwriting gets a little bit better. And you can see I have here copied the definite integral. And so the first thing I'm going to do is I'm going to deal with all these signs. So here I'm going to subtract, this is negative, and I'm switching to 1/2 because it will be easier to take the antiderivative of, plus 3, so negative went to both, dx. And this is not my night for the camera. It has not been happy with me at all. Bring it back up. Okay. Plus 9 to 16. And here this is just going to fall out. So this is square root of x minus 3. And oh, camera got me messed up here. I want to change this to 1/2 as well. Okay, dx. Now you could do these at the same time, but I find it's easier to do them one at a time and just add up the answer, because really you have two separate integrals. I treat them as such. It's just easier for me to concentrate on one and then move on to the other. So I'm going to start with here. So this, I'm going to add 1, 2 over 2, so this becomes 3/2. So I need to bring this out here. So this is negative 2/3. I have a negative out here, remember. X to the 3/2 plus 3x. And now I just applied this. So I don't need this here, but I need this here at the end. Okay. You notice how the erasing, I erase just as much as anyone else does. Okay, so now what I do is I apply this 9 first to here. It's negative 2/3, 9 to the 3/2 plus 3 to the 9 minus. This all becomes 0 plus 0. Okay, that's all going to go away. That's nice. The other half is not going to be so nice, I can tell you that. Okay, so this, first take the square root of 9 is 3. 3 to the 3rd is 27. So this is negative 2/3 to the 27 plus 27. This becomes 9, so this is negative 18 plus 27. And I can write. So this is 9. Okay, so this is 1/2. Now I need to do the other half. So let's take the antiderivative first. So this also becomes 3/2, so this is 2/3, but you'll notice it's positive now. 3/2 minus 3x. You'll notice here the sign changed. 16/9. Okay, so now we're going to have this two-part here. And actually, I'm going to bring this down to here so I can write this out so you can really see what's going on here. And I'm going to do this in two parts. So 2/3, 16 to the 3/2 minus 3 times 16, okay, minus, now the whole other half. Remember, you have to do these separately. They are not one unit. This negative applies to this whole answer, so you have to find everything in the brackets first, then subtract. And that's a very easy mistake to make, hence why I use all these huge brackets to remind myself of what I'm doing. Okay, so this, and you can get your calculator if you want, but what this is this is the square root of 16, which is 4. 4 to the third is 64. 64 times 2 is 128 thirds. Minus 48. Yes, quite the mess. Okay. Now over here, we've already done this. This is 27. We did that up here. Applied this. This is 18, remember we got, but it's positive. So 18 minus 27. Okay. Now I just get out my calculator. I mean, obviously you could do this in your head, but at the same time, you've got other things going on in your mind. Okay. And it helps if I apply the right things in my calculator. Okay, so this is negative 16 thirds. Okay, this is minus, this becomes negative 9. Notice why this is important. These two are going to cancel out. So I have negative 16 thirds plus 9. So if I do out the math, that's 11 thirds. So this goes back up to here. So I have 9 plus 11 thirds. So that is my total area. So then I'm just going to add these up here. And this is 38 thirds, or 12.667. For the most part, my stats lab wants the fraction, not the decimal. But all of you should have some sort of graphing calculator. Mine will convert the decimal to the fraction for you. And like right here, since I'm trying to go and not bog you down and doing all the different parts, and obviously you're concentrating on the calculus, let the calculator do the easy part for you. Just to show you where this is in mine, I'm going to clear this out and I'm going to show you this. So like if I put in 1/3 here, I get this long decimal. Now if I wanted to go back to this, I didn't know what this was. I go to second math, this is my math menu, and I go to F5 to get more, miscellaneous here, it says miscellaneous, and I go to more, and on my more menu is this arrow fraction, and if I push it, it takes the answer and makes it a fraction, and now we're back to 1/3. So check out your calculator. It could very well do some very annoying algebra for you, because obviously we could have done this ourselves out and found each common denominator, but it would have taken us an extra 5 minutes that you probably want to spend on the next problem versus this one. Okay, so let's go back to here, and here's the answer. Let's check, make sure it agrees. Yep. So when you're looking at this, when you're writing this, you're really just subtracting the two equations. And if you have the x-axis is just 0. Now obviously that seems simplistic, but at the same time it changed our sign. So it's very important to pay attention to if your graph is above or below the line and what that does, because of course we had to distribute that negative sign to the entire part. And again, you can see with all this different work I had to do here, it's very careful to pay attention to the algebra as you're going through it. Yes, taking a hint from your calculator, letting it do the fraction work helps. There's still a lot of order of operations you need to be paying attention to. So take the time, write it out, and you will find that these problems are not that difficult. They just take time and a lot of paper.